right. Well, welcome to Code PaLOusa, day 2 of sessions, day 3 if you include the workshops. I hope everyone has had a wonderful time here so far. I know I certainly have. It's one of the best conferences that I've attended in any format. And this is my first time attending Code PaLOusa, so it's been really great. I hope you all share that experience. But let's get into SQL screw ups and how to avoid them, or depending on how you think about it, how to not be one. Um, we're going to talk about the the things that I've screwed up in my career, and when I started looking at some things that I might be doing wrong, I thought, there are probably a lot of other things that I've been doing wrong. I found an issue or two that I had with some SQL, and I said, "This can't be the only thing I've screwed up. Let me do some research and see what some common mistakes are." And turns out I had been making um, a lot of the common mistakes. So um, I wanted to, uh, kind of have a platform to share some of my mistakes with everyone, and hopefully you can avoid some of them. Now, I will say that this is not necessarily for the DBA who is in SQL and fine tuning queries and just on point with all the different things. This is more for the people who are where I was a couple of years ago when I discovered that I was making these mistakes. I was about 4 or 5 years into my career. I was leading a fairly large initiative at my company, and I was writing terrible SQL. Now I'm a full stack developer. I do back end, front end SQL. I define my own tables and all these different things. So they really trust me with a lot of things. And I'm not a SQL expert by any stretch of the imagination, but am responsible for shipping products at work. So we'll just get into some of the issues that I have had. Okay, so I doubt that we'll get through all the content I have. I think, 7 issues that are common, but I want to deep dive into those that you all think are important, but also the ones that I think are important. So I've got these slides in kind of priority order, and at any point, if there's something you do not understand or that you want more information about, uh, feel free to just pop in the chat here, and I know that at least some of you know how to use it. And um, just say, "Hey, could you go into detail on that, or ask specific questions, or whatever you want to do there?" And we'll get into it, because these things, especially the first several, are things that you'll absolutely need to get right in your SQL. And here's the other thing: I will pull up my contact slide here, and at the last minute, I added my Twitter handle to the top right and my website to the top left. So this page is kind of redundant, but while you're looking at my contact information there, I will say that when I discovered I was having all these SQL problems, or that I was not aware of some of these problems that I may have been introducing into the code, I thought about the last 5 years of my life. And what SQL have I written? How many times have I, committed just terrible SQL unknowingly because I wasn't watching out for these issues? So hopefully that'll help you out. Now, I am using a sample data set in this slide deck here. So I wanted to, while this is not a workshop and there's no expectation that you would follow along with anything that I'm doing here on your own, I did want to offer some resources to play around with some of this stuff, and I like free. So these are all free things you can get to go and build a scenario and test out some of the SQL, and I will make these slides available after the session. I will post in the event chat so that even after the session is over, you'll be able to get a link to these. And I will also put a tweet out about it. So whichever way you care to get that information. All right, so here we have SQL Server Developer Edition. And so we used to rely on Express Edition, which had a 10 gig limit. That's still available on the bottom right of the screen here. But, and I think, provide links on every slide where you can go download something or go look at something. So Developer Edition, though, is, I think, a relatively new thing that they're offering. It is free, but it is certainly not okay to use in production. It is for development and testing, whereas I think Express Edition you can use in production, but it's got that 10 gig limit. So there you go. I recommend Developer Edition. And then, so that'll get you a SQL Server going. And then you're going to need a database. So I recommend the AdventureWorks simple databases. They are, some people use them as reference implementations. I'm not sure that I would go that far, but they're good. There's a 2017 version, a 2019 version. If I were to scroll down on that page, there are other versions that we could get. And so you're going to want to restore that database. If you download it, you're going to want to restore that on your server, and that you can find tons of tutorials on how to do that. It's like 3 clicks. I will say, if you're going to do that, you do want to put that probably like in a pretty shallow folder structure. So like when I downloaded it last night, it goes into my downloads folder, which is, like 4 or 5 folders deep on my hard drive. And for whatever reason, SSMS, which is what I use to interact with the database, did not want to drill too deep in to find my files. So we put those on the root or 1 level deep. So you can figure that out. And I will say also, if you're looking into some of these things and run into any problems, later today, in 3 weeks, in 3 years, contact me. I am more than willing to help anybody out who's trying to learn and get through some things. So then once you restore this database, you're not really going to have any data. So there's a way to generate data within these sample databases. And my friend and colleague, Eric Anderson, has a great blog post on this, how to generate sample data from one of these AdventureWorks sample databases. So it's pretty neat. They build in ways to generate a bunch of test data. So that's pretty awesome. So check out his blog. He posts weekly, and it's usually very, very good content. So there you go. But I will say, if you subscribe to his blog, you better go subscribe to mine first, because he, that whole thing, I'm referring him. He has much better content and more frequent content. Okay, so let's get into it. User-defined functions. Now, this is not really, user-defined functions themselves are not a gotcha, but there are some gotchas around them. And we're not going to talk about the broader user-defined functions. We're going to talk about a specific kind of user-defined function. So we want to go through the definition and make sure we all understand what a user-defined function is. And I have a link here if you want more information on that later. But a user-defined function is going to be like a function in a programming language. It's a routine that accepts parameters. I could read the rest of this slide, but you're going to want to use a function if you have some logic or some calculations or something that is repeated frequently throughout your code, your SQL, and you want to just be able to call this function. And if your logic around that operation changes, you want to be able to change it just in the function, and then everywhere you call the function is updated as well. All right. So very similar to functions in say like C# or any other programming language. Now, the thing about these user-defined functions in SQL is they're not allowed to cause side effects. And what that really means is I can't put an update statement in a user-defined function. There are ways to do that called stored procedures, and we'll touch on stored procedures in a moment. So that's really, for me, the difference in a user-defined function and a stored procedure is that uh, a user-defined function is not going to be able to modify data, whereas a stored procedure will be able to modify data. All right. So scalar valued functions. So these are user-defined functions. This is a type of user-defined function that returns a single scalar value. So if you, well, I guess we have examples here. Calculate extended price from, say, like an order line. You have a quantity times a unit price, right? So you could wrap that functionality into a function and just call it anywhere you needed to calculate your extended price. And that's one of the examples we'll go through this morning. Another example may be convert water from gallons to pounds. And so it would take gallons and then it would give you pounds. And so the common thread here is that each of these functions are going to give you a single value. They're not going to give you a table. They're not going to give you a tuple. They're not going to give you anything but a single value. So um, that's a scalar valued function. Now, other user-defined functions could be like a table valued function that could give you a result set. So we just want to be sure that in this case, we're talking about scalar valued functions, but some of the issues may also apply to other types of functions. All right. So here's our order line extended inline calculation. So this is, I say inline because we're doing the calculation in our SQL here. And it's a good time to go over some of the database structure here. So we have a select statement. So we define our columns that we want to select. We have a from clause that has the schema and the table name. So I know some folks are not so used to using schema, which means probably the schema that they use is DBO. That's fine. I prefer to use specific schemas that we create, although I'm not allowed to do so at work. But in my personal projects, I do. It helps me keep the different tables and things separate. And so here you will see sales order detail. So that's just a sales order detail table. And then we have a basic where clause. So we have sales order ID, which is the order number, right? And so it's going to be a PK there, and it's a type big int, and then we're going to order it because we want to do that. So um, we're gonna get some order information, and then we're going to calculate this extended price for a line item on the order. And so this is going to get all of our order lines for this particular order and simply just extend out that price. It's basically a receipt, right? Well, let's say that at some point we say we're not really dealing in dollars. We're not dealing in US dollars or other traditional currency. Maybe we're going to deal in Bitcoin because at some point that was all the rage and maybe still is. I don't know. And since I don't know anything about Bitcoin, we'll say that you can trade Bitcoin, not in the whole Bitcoins or even in the hundredths of Bitcoins, but maybe the 10,000ths of Bitcoins. So that's 4 decimal places. So our rounding on the calculation of our extended cost is going to need to change. Well, if you're working on an enterprise application or a line of business app or even just a large consumer app, you may be doing a calculation like this in several different places. It's not uncommon in my professional gig to have situations where we do something like this in 50, 100. One of the things I replaced recently, we had over 1,000 instances of it or 1,000 references to it in our code. And well, how nice would it be if we didn't have to go to all 1,000 instances of it and and change it, we should just pull this into a function and reuse that code, that calculation in all our different places. So we could simply change that 2 there in our round to a 4, and it would be good. Now we're not going to do that. We're going to leave it as a 2, but we're going to kind of refactor it as a function. Now this is how you create a function in SQL, and it's your basic syntax here. You're creating something, so you have a create. You tell it what you're creating a function, and you give it a name. Here we have the sales schema with the name of our function being get line extended. The next thing we have in parentheses is our parameters or inputs to the function. So you have quantity and unit price, and you want to set your types there for those. And then you want to tell it what to return. Now this one returns money, and here's a good example of trying to find all the instances of something in your code and missing one. I do not like the money type, and you can do your own research on why you shouldn't like the money type in SQL Server. But normally I would do like if I were converting from a money, which is basically a decimal 19.4 with precision loss, I would define that as a decimal 17.2, because that's going to be equivalent for a 2 decimal place money. All right, so you want to tell it what it returns, and here it returns a single value, so it's not a table or anything like that. And then as says, okay, well, this is really the guts of the function, so we do a begin and an end to kind of wrap that. We could make this less verbose. The guts here, we have a declare, a select, and a return, but I really did want to make this pretty explicit for anyone who's not familiar with these sorts of things. So we're declaring a variable here. Some people aren't familiar with variables in their SQL, but you can just declare it like this, declare extended as a money, and then we can select it or set it. There's a set operation we could do. And we're just going to do the quantity times the unit price. It's the exact same logic. So there you go. Easy peasy function there. I'm not going to lie. The syntax here is not something I would get too caught up on. I did want you to understand what's happening here, but it's something that every time I create a function, I do it so rarely that I have to Google it or go find another function that we've written or something like that. That's not really the point here. The point here is that we can do this. So let's see. Jan says, I don't see the function as created. Sorry. Well, I can now. Well, very good. I'm really glad, Jan, that you see the function as created. All right. So that's the basic construct of a function. And so then the only thing left to do is replace our original code with a call to the function. All right, well, it's basically this exact same query. The thing we focus on here is the red box, and we're calling using our schema, which is sales.getLineExtended. We pass it the order quantity and the unit price from our sales order detail table. So those are you can see we have order quantity as the second column that we're selecting there. But unit price also exists in that sales order detail table. And so we can simply call that function right there and pass things from the table that we're in. Cool. Well, that's pretty easy. And in this case, you don't really gain a ton other than the reusability of the logic. Here, your SQL is really not any less verbose. But when you get into larger functions that do a lot of things, then you can save some keystrokes and make your SQL a little bit easier to understand, and that's kind of one of the points too. All right. So You're like, "Evan, you're supposed to be telling me, things that are gonna screw up here, and nothing really looks like it's gonna screw up yet, right?" Well, you're right, like, there's nothing wrong with anything we've done here. But let's say that instead of, uh, getting just the single lines for the function and kind of, or the order rather, and printing a receipt, let's say we want, kind of an order summary, um, query here. And so this is a little bit different. Have, um, we have orders, and this is some different table names. Try to simplify it a little bit. So we're selecting from orders. We're joining customers. We have a left join to order lines and a left join to items. And so say that um, to get the subtotal for the order, we don't want to display each individual line item on the order. We just want the subtotal of the order for our order summary. Well, it's the exact same calculation. If you look at the red box here, we have a quantity times a price. And we're rounding to 2. Cool. Well, we can do that all day long. We could probably even use the function we already created for it. But the other thing we're doing here is we're summing it, right? And so we have to sum it, and then because we're summing it, then down at the bottom we've got the group by, uh, and we don't really care about showing anything from the order lines or showing anything from the items. We've joined items and order lines here only to get the subtotal. So what if we could make this query way less verbose and simply write a function to get the subtotal given an order ID? All right, well, let's try that out. Refactor that bad boy as a function. We got the same kind of syntax here. Create a function, give it an order name or a function name. We're going to accept an order ID as the input to this function. It's going to return a decimal 17.2. I did update this one. And so same kind of pattern here. We're going to declare our subtotal variable, and then we're going to select subtotal equals the exact same calculation that we did in our previous query. From orders, we're going to join order lines here. We're going to join items to get our quantity and our price. We're going to group it by the order ID, and there we go. Filter it to the order ID that we're interested in. We're going to return that subtotal. So uh, that's really no different from refactoring in any language. And so this kind of shows you that we can write a function for more complex logic. And so this is the exact same query that we had 2 slides ago. Uh, the original one where we were doing the calculation in the select clause, and we had those 2 outer joins, and then since we were summing in our select clause, we had to group by all the other non-aggregated columns in our select clause. And so this is a situation where why in the world would we not want to do this for a lot of different things? It's way easier to read. I don't really care if I'm getting an order summary. I don't really care how we get the subtotal. I just know that I need to get the subtotal. And especially if you're writing functions for other people in your organization or your team to use, then this is really nice because they may not be an expert in how the order and order line, the whole pattern works. And in this case, they don't need to because you've written a function for them to use to get the subtotal for an order. They don't have to know all of that. Well, yeah, you'd be right if you said all that. Simplified query, remove joins, remove group by. I would much rather write this query than the one we wrote before. All right. Um, so let's look at this. What does it actually do? Well, just like we can refactor some code out of a query to get to create a function with it, we can also, and probably should in a lot of cases, go the other way around. And once we uh, refactor some code out into a function, we should maybe kind of just slap some parentheses around it and paste it back into the code where we're calling it and see exactly what it looks like. So all I've done here is I've taken our simplified query from the previous slide and I pasted the guts of the function we wrote in there. And so what it results in actually is a terrible performing thing. We have a subquery inside our select clause. Now, none of us can predict what in the world SQL Server is going to do with this. You just don't know. You can run a query in SSMS, that's SQL Server Management Studio, and you can get an estimated execution plan, and that'll tell you some things, and you can kind of optimize your query a little bit that way. But you don't know actually how SQL Server is going to run this. It has an optimizer that's going to take some of the things that it already knows and some indexes that you've provided, and um, probably do some quantum computing, and it's going to figure out how it wants to run this thing. And it's not always going to run it in the same way. It's not going to run things in the same order. It's not going to evaluate things uh, in the same way every time. So uh, there may be a situation where you run this and it is perfectly fine and no performance problems, and SQL knew exactly what to do. But there are other situations, and probably the more common scenario, where it's going to execute this subquery, so the part in red, per row of some result set, right? So when I talk about you don't know in what order SQL is going to apply things, um, there are situations where you could apply a filter to the larger query here, and it's going to maybe narrow down your result set. Inner joins can be filtering, so it may do that first. There are other situations where maybe it's just going to select a ton of stuff and do things in the select clause first. So the point here is that in SQL, you're really trying to operate on a result set. And when you put something like this in a select clause, a subquery here in the select clause or in the where clause, then it really does have to evaluate that subquery per row. And if you think about it, this subquery that's aliased as subtotal is no different from selecting the orders.id column. You get a different value per row. Well, how do you get a different value per row? Well, it evaluates that call per row. So this is the problem here when we start querying a bunch of data in a scalar valued function, is that performance becomes terrible. Now, I'm pretty big on stories, and we're going to speed up here in a minute, but I do like uh, to share my experience, and this is really the big turning point for me discovering all the problems I had with the SQL I was writing. I had a query, and I was left in charge of a large initiative at work, and I had a query that needed to get the status of say an order, for example. And well, the status of the order really depended on some kind of subcomponents. There were a lot of sub transactions that happened in orders. We had discounts and adjustments, and you could do all kinds. You split it up different ways. It was crazy. Uh, so the status of the order depended on the status of the different ways you could split it up. And each of those splits had discounts and adjustments. And so the status of each split depended on the status of each discount, whether it was settled or not. And each split also depended on the status of each adjustment. And so I was like, well, I could just get a status here in a function. So I wrote a function to get the status of an adjustment. I wrote a function to get the status of a discount and of an application, of a split, and then of an order. And each function from the higher part of the hierarchy called a function from the lower part, called a function from the lower part, right? So I stacked a bunch of these functions, and each of these functions had super complex queries and joins and all kinds of things. And then one day I got a call, and we call it the debacle of fall 2018. I got a call. Clients were down; they could not do business, and this is their high volume part of the year, and this is the high volume part of the system that was affected. And so that's when I discovered, you know what, I should avoid querying additional data in scalar valued functions. The query plan estimator that I talked about before, because I am concerned with the performance of my queries. I try to look at that whenever I write a new query. It returns a zero cost for scalar valued functions. Presumably, quantity times price is going to be zero cost compared to everything else in your query. When you start querying a bunch of data inside your scalar value function, that's no longer roughly a zero cost. And the query plan estimator just assumes that you're not doing something like that. Now, newer versions of SQL Server are improving, uh, and they are improving both on I believe, the query plan estimator aspect of it and the optimization of functions, but don't trust it because you don't know what it's going to do. All right. So we'll get into stored procedures. So stored procedures, similar to a function, you create it, you give it a name, it does some stuff. So the Microsoft documentation, which has greatly improved over the past couple of years, says it's a group of one or more transact SQL statements. Cool. We can handle that. It's basically a function. But you can do updates and deletes and different things, inserts with a stored procedure. And that's the basic difference there. So if we want to get our sales, this is how we might write a query to get our sales. And this is an example of maybe getting sales, all of my online orders. If I'm customer 11091, getting all my online orders from when I was 24 years old. So the devil's in the details here of the where clause. Order date greater than or equal to my birthday in 13, less than my birthday in 14. Online order flag is 1. The alternative there, that's a bit. The alternative there would be a 0. And then filter it down to my customer ID. Cool. Pretty simple. Pretty simple query there. So let's refactor that as a stored procedure. All right, well, create. We got to tell SQL what we're creating. We're creating a procedure. We'll give it the schema and the name of our procedure. And then the green box here, if you can see green, but it's the top box, is inputs. And so we tell it the inputs that we expect, just like the function and then we wrap it in a begin and end. And so the guts here is basically a copy of the query. Now we replace, like any good function or stored procedure, we replace the literal values, the dates and the bit and the customer ID with the inputs that we accept to our function. And it's that simple. Again, I will say, if you're not so familiar with stored procedure creation, then you can Google that. I do quite often. All right, so let's use it. Well, this is another situation where it was such a simple thing that it doesn't really reduce the verbosity of our call here. What changes is we use the keyword exec, and then we give it the name of our stored procedure, and then we set the inputs to the values we want, and there you go. Hit F5 and it executes. Cool. So one of the things that is really nice about our stored procedure is that I don't know if you noticed, but I will go back a slide and show you uh, where we declared our inputs. On the right side of those, we have equals and a value. So equals null, equals 0, equals null. And so those are default values. Technically, I could totally omit one of these inputs in my call to that stored procedure. And as long as I've got a default value there, it will use it. And here I'm doing, the named setting of the inputs. You can do positional inputs as well. if you're familiar with those concepts, in which case, if I wanted to, um, if I were using positional arguments and I wanted to get the default, there's a default keyword that I could use for that. That's not really the point of this talk, though. So, uh, what we want to do is handle those defaults because before, and let me just go back 2 slides here. If we look at the guts of this in our where clause, if order date, say my input order date range begin is null, then well, we don't really have any order dates that are greater than or equal to null. So I think that's just going to give me no results when I call it. So we want to handle those defaults. So the way that we would do that is we would say order date greater than or equal. If the order date range begin input is null, then we're going to use kind of the beginning of time that we could fathom here and represent in SQL. And then the same goes on down the line. If the input is null, then use some value that is going to give us pretty much everything. We're going to try to disregard the whole thing. So on the dates, we say give us the big dates and the little dates. On the online order flag, we say if the input for online order flag is null, we're going to use online order flag, which is the value of the online order flag in this record, right? So this is what happened a lot for me at work, but it's not something that I recommend necessarily because there are some implications there. So say I actually wanted to find the orders where the online order flag actually is null. Say we don't know if it's an online order or not. I don't know where it came from, but let's just say, and we wanted to get all the orders where the online order flag is null. Well, if we pass null in as our online order flag input, then that filter is just not going to apply, right? So there are definitely problems with this, and but just know that this isn't the best way to handle it. But it's the way that someone might handle it in production if you're not careful. So then we can call it differently. We have the online orders. This is basically the same as the first call, this first execution of it. It's basically the same that we've seen before. Then we've got the second execution of it is get all my orders when I was 24, right? So we just omitted the online order flag. And so that's going to take the stored procedures defined to default for that input as null. And then since we handled nulls with the is null function, we get results. So that's a thing. Now, there's another way we could do it. We could get all online orders, not filtered by date or customer or anything like that. We could do that. That also works because we handled all our nulls. Anything that's null is just not going to apply as far as filter. So story time. All right. The large initiative I was in charge of at work, or that I am currently in charge of at work, I was not always in charge of at work. We had a lead who was notoriously a foot dragger and just, hey, we could do these great things and provide awesome value to our clients. We just need to upgrade to .NET Framework 3.5. No. We won't get into all that. It was not a thing that we could modernize anything or use current programming languages or anything like that. So when this initiative started, he decided that we would smash this stereotype and say, you know what, we're modern. We're going to use stored procedures. So the backstory there is that all of our wildly successful apps, and I mean that sincerely, they are good apps that make a lot of people a lot of money. They all used inline SQL in code behind for the UI. And it's hard to knock it because it works very well, but not something that we wanted to do going forward. So we started implementing a repository pattern. And so it doesn't really matter if you're writing the SQL in your application code, if you're using a repository pattern, or if you're calling store procedures. You can do it either way. It doesn't matter. Um, the point though with the repository pattern is to not repeat similar. I won't say the same, but not repeat similar SQL in a bunch of different places. So you have to go update it everywhere. And I say similar because there are a lot of cases where it should have been the same SQL, but it was different in places depending on who worked on it or who was aware that we called the or needed to query things in different places. So we're going to try to make this long story a little bit shorter. Uh, this lead made an arbitrary decision to use stored procedures, I think because it would make us look a little bit more modern compared to the rest of the app we were working with. And so some things that happened were the database tools that we were using really captured changes in the schema, right? So that's something you want to consider if you're doing database development. Is your the state of your schema really is an amalgamation of changes or migrations to the schema. It is not necessarily a declarative thing, and it's that because when you make changes to your schema, you may need to backfill some data. You may need to modify the data as well as the data definition, right? So you definitely want that to be the case. Well, if you're doing that migration-based SQL deployment, then your version control is going to have alter statements for your store procedures rather than create and or drop and create. So what that looks like is you don't know what changed in your store procedure when you're looking at history and version control because you're just adding a migration with an alter that has the entire store procedure definition, right? If we were doing if we were just maintaining create scripts for these things and we could change or we could see over time how the creation of the store procedure changed, we see the definition changes, right? And then there was a situation where we shared SQL repositories with maybe some other teams in the company, and our deployment scripts were not great, and so only clients who used the module I was working on got these stored procedures added to their databases, and other clients running the exact same app did not get the store procedures. And so when my team implemented things that used stored procedures and then other teams used the same components, then their clients would blow up. So it wasn't a great situation. All right, so fast forward a little bit. Evan takes over. First thing I did was rip out all the stored procedures. Now, it's not because stored procedures suck. Stored procedures are great and they have their place, but their place is not mixed in with a bunch of code that's not going to support it. Now, here's the situation. The problem was that we had to integrate with other parts of the applications that because they had inline SQL everywhere in their code behind of their UI, they would just pass around SQL predicates here and there. Like you could write some code and you would never know what kind of where clause or what kind of things would be tacked on to your where clause because it would just be like injected from other places. Now, that in itself is a crazy thing to do, but it was working, so it kept happening. And so in our stored procedures, for example, and this is the reason it was a bad call in our case, we'd have a simple query like this. I just want to filter where my order ID is 101. I can do that pretty easily. But I didn't know that I was going to be filtering on order. Uh, I didn't know, and the other parts of the system weren't able to call a store procedure and give me those um, specific inputs. They didn't really know that they were querying for an order ID either. They were just like passing a string along and calling it SQL. And so we ended up having to do things like this. You see the bottom execution here, that's calling a stored procedure, and it's got a single input, and that single input is actually going to be a predicate, a where clause here. And so this is a simple version of this. Go back to the order ID thing. We would have to create this procedure, and then we would our actual input has got to be a variable length character max, and we got to build this query as a string. We're not even working with SQL here anymore. We're working with a string. We're going to tack on the SQL filter that was passed in, right? And then we're going to do an execute SP execute SQL on that query string. Now, under the hood, SQL does this a lot, right? That's fine. In certain situations, it's fine to do stuff like this too. You just don't want every complex query in your system to do that. And so to call it, then that's the second arrow down here to call it, execute the store procedure and pass it the predicate. Well, you you have to start escaping your single quotes in your SQL. So now a single quote becomes two single quotes, and you got these things wrapped in, the whole predicate here is wrapped in single quotes, and then the 101 value here is wrapped in two single quotes. And yes, Edward, you are right on the money. No, no, don't do this. But listen, man, we had a ton of stuff doing. I mean, we had like stored procedures that were hundreds of lines long, and then called by other things that were doing this. And I would be lying to you if our defect count didn't increase when we started doing that, right? Um, yeah. So now you're talking about SQL injection, and uh, the good part about this is that our our store procedures were only available from within our app. You only had developers interacting with it. Still dangerous, but it wasn't a situation where we could ever have a SQL injection problem. Um, and that may be more a result of our user base or something. I don't know, but yeah, that's also a dangerous thing. So that leads me to another point. Always use parameterized queries when you're writing your code to help prevent against SQL injection. Okay, so this is uh, what was happening, and this is probably pretty difficult to see. And I guess that's kind of the point. When you had a stored procedure that had some expected inputs, like the original ones we had in our first stored procedure, then we add on, if you can see at the bottom of the inputs, is Wild West SQL is what I call it, and that's that predicate that gets passed around within the app. And so what that means, though, is that we have to convert the rest of our guts of our stored procedure to a string, and so introduce all these extra single quotes, and it's just not readable. It's not very debuggable. It's just a terrible thing, right? And so you don't want that. Uh, the thing that you would end up wanting to do with that same code, though, is you would want to build dynamic predicates here, so you could get a good execution plan, and the SQL Server could cache that and all these good things. And so it ended up looking a little bit more like this. So on top of the parsed SQL strings and whatnot, you have some extra logic on there to check for null things and whatnot. So you don't always have the same query giving very different results. And so that was also a bad thing. And so here's my rule. This is literally all we needed to do. We didn't need to use stored procedures. We just needed to write our SQL inline in our new repository pattern and be done with it. Like it, and so there's no telling how much money um, was spent on first figuring out all these problems, fixing them, converting all of our SQL in our module to to store procedures, and then let's see. Edward says we look fine. Okay, Tom, we're good. Matthew, maybe refresh. I'll go slow for a minute so you can catch up. If well, Matthew can't hear me, right? Can I'm going to continue. Can someone kindly ask Matthew to try to refresh and come back into the session? Because we got just a few minutes left here. Thank you, Brad. All right, but I certainly don't want to leave anyone behind. And if anyone wants to sync up later, we can and talk about some of these things. So store procedures are not a silver bullet. You want to have a reason to use them. You want to evaluate the impact. And this is really with any change you make. You want to evaluate the impact that they're going to have on the team and your products. And there are certainly great reasons to use store procedures. But when you find yourself doing really nasty things like this, just don't. And you may not have that option. In my case, I could not say, no, we're not going to use store procedures. We're going to cover null. And there's a setting on your SQL Server. Welcome back, Matthew. There's a setting on your SQL Server for null, whether you want to use ANSI nulls or not. And if you're not familiar with the ANSI SQL standard, I recommend reading up on it. It could be some boring reading, but it's good to use ANSI SQL where you can for consistency and for other people to be able to read it and whatnot. But check out the ANSI nulls setting, and that's going to affect some of what we talk about here. But for the most part, it's going to be defaulted on, which is good. The concept here is null, and I don't know if you get the title of this slide, but null is not equal to anything, and null is not even equal to null. Well, what do I mean by that? If you get orders that don't have a comment, right? You might say where your comment equals null. Well, that's going to give you 0 results when ANSI nulls is turned on, which it is by default. And you're like, well, wait a minute, I might have some comments that are null. And let's assume in this data set you do have some comments that are null. Why does this not work? Well, because null is not equal to anything. So if you look at a single row situation where the value of your comment on a particular row is null, then your predicate here is saying where null equals null. And so that's kind of my point, is null is not equal to null because null is not equal to anything, not even itself. Well, so you say, well, let's say where a comment is not equal to null. That should at least give me everything, right? Nope, because null is not equal to anything, even null, right? So null is not equal to null. Null is not equal to null. I don't. It seems like a conflict, right? So here's what you do: comment is not null. So I see null has 2 characters and compared. Yeah, that's a good thing. We'll go over that situation here in a minute, Calvin. So you might have a situation where you don't know that you're dealing with null, and especially you have situations where you have an input to a stored procedure or a function that ends up being null, and so you could inadvertently compare to null. And so it's a really good idea to always consider what happens when my value is null, or what happens where, like, if instead of we have null over here, we're saying equal to some parameter or input value. So we want to say is not, right? We could do a value is null or a value is not null, like in this case, or we could even put a not on the front. We could say where not comment is null. I find that a little bit less readable. So the other concept here, and this is where we'll get into Calvin's comment, is that null is not the same as an empty string, right? You're like, well, if you don't have a comment, you don't have a comment. It's the same as an empty string. Well, then you can enforce that. You could handle both situations. You could say if the comment is null, in this second example here, if the comment is null, we're going to replace it with an empty string and then compare that to an empty string. We could say if the comment is an empty string, we're going to replace it with null and compare that with null. And that's fine too. Now, what I would do though is in the situation of a comment or a lot of different strings, if your null value is logically the same thing as an empty string, or say an integer value is logically the same thing as a zero, then go ahead and make that column not nullable and give it a default of the thing that's the same equivalent as null, and that might save you some time and headache on querying. So here's a quick thing about the ANSI nulls. There's a link there for anyone who wants to look at the slides later. And then in the next 2 minutes, we'll just go over filtering on joined columns, right? So you're going to do an outer join, and then you're going to, in your where clause, you're going to filter on that column, right? So in the first example here, we're left joining on store, and then we're filtering in our where clause from something on that store record. And then in the second one, we're outer joining on sales order header, and we are then in our where clause filtering on some column from the sales order header deal, right? Well, the fact that we have an outer join means that even columns that are not nullable in that joined table can come back null because you may not have a match on your join condition, right? So in both of these where clauses, on the first one, we're comparing potentially a null salesperson ID to 281, and in the second one, a null order date to 2014, and it's just going to give us nothing. Okay, so you can do is null, right? It's a good idea. Anytime you're outer joining to a table, it's a good idea to think, what if this comes back null? Because it can. So you can basically, if you know the value that you're filtering to, you can say, well, if the salesperson ID is null, we're going to replace it with a 281, compare it with a 281. You can also do that with inputs and variables. You could replace your 281 with a variable. And then in the second example here, it's a very similar situation, except for we could actually put the filtering in the join condition. And I'm less a fan of that because it's less just like obvious that we're filtering here. But you could certainly do that if you only wanted to join the sales order headers for that condition. So that's a way that you could do that. And then we will basically go over to, we're going to gloss over type mismatches because it's important but less important. In this query, city is an in varchar, and Nashville is, I assume care. I don't know how it does this. You could convert Nashville to an in version of that by putting an in before the first single quote. That's not something that's very obvious though. Like nothing wrong or nothing looks wrong with this query, right? So you really want to look at your data and your schema, and there's a way you can get help with that. It's a built-in store procedure. It also exists on the temp DB. You would it's exec sp help, and then you give it in wrapped in single quotes the schema.table. If you're using DBO and that's your default schema, then you don't have to put the schema up there. You could just do address in that case. It also exists on the temp DB. You could do exec temp DB or temp underscore DB dot sp help and give it the name of a temp table. And it basically gives you all this. Well, this isn't very readable, but it gives you a lot of information, probably all the information you would ever need to know. This is what I'm talking about here, though. It gives us the data definition for all of our columns. You can see that city is an in varchar here. We were comparing it to a character. It's going to be a performance thing. Speaking of performance, cursor and while. My short version is avoid it when possible, because here is just some snippets, very small snippets from a very large cursor that it just won't all fit on one slide. And I don't even go into the construct here because in general, you shouldn't need to use it except for maybe like once per app for special situations. And then we have sargable predicates, which is basically you have a PK or an indexed column. Like here we have in our first where clause last name, and we want to get records where the first letter of the last name is S, as in Smith. And so we're just going to get the left one of the last name compared to S. And that's going to deem all of our indexes unusable because we're performing an operation on that. So it has to do it per row. The alternative, where you could still use your indexes, is to use wildcards, last name like S%, and that's going to solve that. So I really recommend looking further into some of these things. I will make these slides available to you. And like I said earlier, if there is anything else you want more information about or have questions about, even looking at the slides later, feel free to contact me, evansmith.dev, and then on Twitter at evansmithdev. And I assume that were there any questions, they would have popped up in chat. I will hang out for probably another 5 minutes to see if any questions come in, and but the session is technically over. So thank you all for coming. Thank you for coming to Code PaLOusa. Definitely visit the sponsors and try to do better. Uh, Even if you're really good, we can always do better. And so if you need help doing better, I deem myself success coach, and I can maybe help you do better. Uh, Ed, thanks for the comment. Tom, I appreciate you being here. Melissa, hope you got something from it. Hope you all enjoyed it. Calvin and Jacob, and thank you all for interacting a little bit. I know it's been a little odd this year, as everyone likes to comment on, but I think Code PaLOusa's done a really good job. I've done both the speaker thing and attended other sessions, and I think it's been a really good experience. So I'm glad that Chad and all the people involved decided to carry on with it, and glad you all came. So yeah, Charles, you're very welcome. Brad, thank you. Are there any questions or anything? You're welcome, Stephen. Is there anything that anyone would like to see? I did want to get to my last slide there within the constraints of the session, but I am willing to go into anything for the next maybe 3 minutes. Just as tired at the end of the day attending virtual. Yeah, I know, Edward. It can be exhausting. And the other thing with the online format is, and one of the things that I appreciate about in-person conferences is that, you kind of get to unplug and get away from a lot of the things. Work stuff still comes up sometimes, but that's one of the things I'm still trying to juggle. Some of the family stuff. I did take PTO for Wednesday through today, but it's tough to kind of unplug from everything, and but it is exhausting. So on top of all the conference things that we're doing and all the sessions we're attending and all the side stuff we're trying to research about, all the stuff we've learned, we also have like regular home stuff that we're trying to work on, and maybe some work stuff here and there. So yeah, so Edward, with recompile, so that's a thing that actually ended up in a lot of our stored procedures, and kind of as a default, that's a thing that we did. And the thing though that we want to strive for, as far as I understand it, is we want cached execution plans for a query. And so the thing that we want to strive for, I think, is a specific query that does not change. And so when you end up having basically the same stored procedure, recompiling and getting different execution plans, then what we've noticed in production is that you end up with cached execution plans that hang around for about 4 minutes, and that's not very long. So it really, and I don't know that that was the big problem there. A lot of the problem was also that um, in a lot of cases for the jank code that I wrote, y- SQL could not come up with an excellent execution plan. It throws its hands up and says, "I give up," and then I'm not sure what it does. I think a lot of times it times out, not just as a result of that, but as a downstream effect. I don't know if it does a lot of brute force, full table scan type things, but it certainly caused timeouts. And then further down the line, when we added some complexity to our app, it resulted in deadlocks. And deadlocks are not something that anybody wants. So one of the hardest things, in my opinion, to debug and fix. So right, yeah, and hints are just that too. I really try to solve problems without using hints, but a lot of times what we find out is that we're just going to toss this in here and hope that it helps. So that's unfortunately the situation that we're in sometimes. So I compare SQL Server things with networking. Um, like you don't really know what's going to happen. You change some settings and try again. And that's probably because I'm not a DBA. DBAs are probably like, no, you have to know what you're doing, which I guess is true. You should know. So cool. All right. Well, I appreciate y'all, and I didn't mention it earlier, but but saying y'all kind of jogged my memory. I'm sitting here in Nashville, Tennessee, so I'm on Central Time. And if y'all are ever in the area, once things clear up, swing by and get some hot chicken. But appreciate y'all coming. And yeah, unfortunately, we we do learn the hard way a lot of times, but that's a good way to learn too, as long as we can recover from it. You're welcome, Edward. So hopefully we'll see y'all in some other sessions and in some of the what do you call it, the networking tab. So I'll sign off for now. Again, appreciate y'all and enjoy the rest of the conference.